All right, welcome back. So we just introduced polygons, some vocabulary that we're using, and two of those specifically are interior angles and exterior angles. Polygon again, just to go over, straight lines connected in some sort of pattern that ends up back where it started. So there's an inside and outside of this two-dimensional shape made of straight lines. So since there's an inside and outside, interior angle is just any angle on the inside, right? And there's the same number of angles as there are sides of the shape. And then an exterior angle is if we extend any side, we talk about the angle formed by that extension and its adjacent side. So that exterior angle right there, which coincidentally is supplementary to any interior angle, right? If you look over at this picture where I'm drawing, if you extend a side, it forms a straight line. So obviously those two are a linear pair. So the interior and exterior angles at any vertex actually add up to 180 degrees. Okay, so let's see what we can figure out about the exterior angles, okay? So notice, and I'll use this picture up here actually to start for exterior angles. Now think about, I was standing in this position and I was looking in this direction. Okay, well I'm going to turn A degrees, and now I'm pointing in this direction. Okay, and I'm going to walk forward a little bit, and I decide to turn again B degrees, and now I'm pointed in this direction. And I walk forward a little bit until I decide to turn C degrees. Again, I keep just turning to the right, so now I'm pointed in this direction. And then I turn D degrees to the right, and I'm pointed in this direction. And finally I turn E degrees to the right, and I keep walking. I end up right where I started, pointed in the exact same direction I was pointed at. So think about that. I was pointing in a direction, and I made a bunch of right turns, and ended up pointing right back at where I was started. So I went full circle, right? I was pointing in a direction, I turn, all in that same direction, I end up back where I started. So that must be a total of 360 degrees, right? So A plus B plus C plus D plus E in this picture would be 360 degrees. That's interesting. Let's try it with another shape here. Let's say I draw a triangle. That's one exterior angle. Here's another. And here's another. Well, let's think about this, okay? So if I start out pointing in this direction, and I turn left A degrees, and now I'm pointed in this direction, I walk and walk and walk, and all of a sudden I turn B degrees, again to my left, and I keep going, and I turn B degrees, or C degrees this time, because these can be all different angles. They don't have to be the same. But if I turn C degrees and I point back to where I started, and I get back right to where I started, pointed in the direction I was pointing, then A plus B plus C is equal to 360 degrees. And in fact, our general rule that's true about all of these is the sum of the exterior angles of every convex polygon is 360 degrees. Now I want to make two little notes here. One note is, notice we're only talking about one of the two exterior angles at each vertex. There are actually two vertical angles formed that are the same. So we could be talking about B here or B here, but when we talk about the sum of the exterior angles of every convex polygon is 360 degrees, we're talking about with one exterior angle at each vertex, okay? We're not talking about adding up both, but if we did add up two copies of every single one, we'd just get 720 degrees. But we add up one copy of each of those exterior angles, and we get, at each vertex, we get 360 degrees. Another little caveat, which I think is interesting, is if we look at concave polygons, so where there's an indent, and I'll just let you think about this, but if you start pointing in a direction and you make a bunch of turns, lefts and rights and lefts and rights, and you end up back where you started, pointed in the same direction, you have gone full circle. So you should have been 360 degrees. However, what you need to take into consideration is when you turn right, those are maybe positive degrees. And when you turn left, those would be negative degrees. So it gets a little wonky. Instead of looking at just exterior angles as, 10 degrees or 5 degrees, you have to think about negative. And that would be, just to draw it out really quick, if you had an indent, think about that. If I extend aside and making a left turn here, and you're on the inside of the shape, we would consider that a negative. And we're not going to do this. This won't come up. But just, it does actually work that it's a 360 degree circle back to the starting point if you took those negatives into consideration. Anyways, just something to think about. So, the sum of the exterior angles of every convex polygon, so no indents in it, is 360 degrees. That's going to be useful. Okay, so let's look at interior angles now. Again, we're only going to consider convex polygons right now, but we'll get to concave polygons as well. Okay, so let's just draw a three-sided figure, right? We know that totals 180 degrees. We used that a lot in the past. Now, what about any four-sided figure? This doesn't need to be special in any way. Just a four-sided quadrilateral. Okay, well, the reason we spent so much time on triangles in the past is geometry is built upon itself. So we're going to cut this thing into triangles. And notice what we have here. We have these three angles adding up to 180 degrees. And similarly, we have these three angles adding up to 180 degrees. And yet, if we wanted to find the sum, and I'm going to use colors here instead of variables, if we wanted to find the sum total of all the degrees in this, let's do this in brown here. If I want to find this angle plus this angle plus this angle plus this angle, what I get is, I get pink plus green. This is one combined angle there. And then plus the next one is green, plus the next one is green, plus pink, and that's my other angle. So I started at this corner here. I said that's a pink, plus a pink and a green, plus a green, that's this one, plus a pink and a green, that's this last one, and I get back to the beginning. So those are my four angles, but look at what I've added up. I've added up my three pinks, and I've added up my three greens. So really, I just have two triangles, or 2 times 180 degrees, 360 degrees. That's interesting. Let's draw now any old convex five-sided figure. Oh, I wanted blue for that. Okay, let's go with a pentagon here. Okay, trying to make it not look regular, nothing special about it. So we're going to go ahead and take one vertex here, connect it to every other vertex we can. Now notice I don't want to draw two diagonals like this, because now I get these weird triangles that have angles that aren't part of my polygon. So I don't want to do that. Let's undo that, okay? Instead, I'll say, well, I can't connect to this vertex because that's a side. That doesn't cut anything up at all. And I can't connect to this vertex. It doesn't cut it into pieces. Instead, I'm going to cut it this way into a triangle and this way into a triangle. And notice I have these adding up to 180. I have these adding up to 180. And I have these adding up to 180. But look, if I add up all of those dots, I exactly get the total of the interior angles, right? That's exactly, if I go all of these dots plus these, plus these, plus these, plus these, that's every single dot. No other angles in there. So I get 3 triangles, or 3 times 180, 540. Let's do just one more. Okay, let's do a 6-sided figure. Again, any old 6-sided figure. Let's do short here. Let's do long here. That's 1, 2, 3, 4. I have a hard time counting, actually. Funny for a math teacher, I know. Okay, so I'm going to, again, take any vertex. I can't connect it along these sides because those are already there, but I'm going to make a diagonal here, a diagonal here, and that's it, because I can't go along the other side. So again, let's add up all those angles. So I got these angles. I've got these angles adding up to, well, why can't I write here? Oh, my wrist was on the pad. There we go. Adding up these. I've got these angles adding up to 180. And finally, I've also got, in red here, I've got these three angles adding up to 180. But look at this again. If I go ahead and say all of these angles, plus this one, plus these, plus these, plus these, plus this one, that's exactly the sum of the interior angles. That's all 6 angles added up, no extra overlapping, nothing. That exactly equals the sum of 4 triangles, or 4 times 180, or 720 degrees. So what I'm finding is, when I had one triangle, or sorry, when I had 3 sides in my polygon, I had 1 triangle. When I had 4 sides, I had 2 triangles. When I had 5 sides, there were 3 triangles. When I had 6 sides, I had 4 triangles. And actually, this pattern continues indefinitely. So for any convex polygon, and instead of calling it a polygon, I'm going to call it n-gon. And all that is a polygon with n number of sides. So an n-gon could be a 30-gon, so n would be 30. All right. Has a sum of interior angles equal to, and there's this formula where we take the number of sides and subtract 2. You notice 5 sides became 3 triangles, 4 sides, 2 triangles, 6 sides, 4 triangles. So the number of sides minus 2 times 180 degrees. Right? So just to translate that, this is the number of sides the polygon has, minus 2 in parentheses, and then times 180. So let's practice 2 problems right here. Just to sum this up, we have just written out and type with a few examples that we just went over. The sum of the exterior angles is 360 degrees. A couple examples there. 4 exterior angles of a square, 360. 5 exterior angles of a pentagon, 360. 25 exterior angles of a 25-sided figure, 360 degrees. Whereas the sum of the interior, we use this formula. So the sum of 3 interior angles of every triangle is 3 minus 2, because there's 3 sides, times 180. So we end up getting 1 times 180, or 180 degrees in every triangle, which we knew, right? 4 interior angles of every rectangle or square, any 4-sided figure, is 4 minus 2 times 180, or 360. And the sum of a 7-sided convex polygon is 7 minus 2 times 180, or 900 degrees. Okay, so let's actually apply this. That's just a summary. Okay, so solve for x. Well, let's see. It doesn't say this is regular, and I can tell it's not because these 2 angles are not the same. So if it's not regular, all we know is how many sides there are, so the total. Right? So there are 1, 2, 3, 4, 5 sides, which means there's 1, 2, 3, 4, 5 angles. So I know these are interior angles, so sum of interior angles, which is n minus 2 times 180, or 5 minus 2 times 180. So that's 3 times 180, or 700. Whoa, not 700. 540 degrees. Okay, so the sum should be 540. And now look at the picture. It describes every single angle, either in number or variables. So I could say, if you add up x plus 86 plus 140 plus 138 plus 59, that should total 540 degrees. So let's do some quick algebra here. That is x plus, I'll combine these two, so 226. I'll combine these two, that's 180, 197. Okay, so that's x plus. Now I'm going to combine these. I get 410, 423, I believe. I might be making a arithmetic mistake here. So we get minus 423, minus 423. And so x equals 117 degrees. Great, okay. Let's go to this other one. So look at this. We've got all the exterior angles, again, one at each vertex of a polygon. And we know, no matter how many sides there are, the sum of the exterior angles is 360 degrees, right? So what we can do here is we can say x plus 59 plus 48, just going all the way around this shape, plus 50 plus 39 plus 58 must equal, yes, started at this one and I went around the shape just adding them all up. That should total 360 degrees. So that's 2x plus, I'm just combining them two at a time, so that's 90, that's 107 plus, this is 89 plus 58 equals 360. So that's 2x plus, that's 196. And I'll subtract this 58 from both sides. And so I'll get that this is equal to 302. Subtracting 196. We get that that's 2x equals 106. Divided by 2, x is 53 degrees. Okay, so what I'm going to do now is I'm going to jump over to IXL and do some practice problems. If you feel comfortable, go ahead and apply this. If not, stick with us for a little bit. Okay, so here we are in G4 in geometry on IXL. So it's kind of a mix of interior and exterior problems. So the diagram shows a convex polygon. What is the sum of the interior angles measures of this polygon? So I know that the sum is n minus 2 times 180 degrees. And so what I want to do is figure out 1, 2, 3, 4, 5, 6. I'm just marking those to count, not to say they're congruent. They could totally be different. So we get 6 minus 2 times 180. That's 4 times 180. So that's 720 degrees. Okay, the diagram shows a convex polygon. What is the sum of the interior angles of this polygon? Again, I just need to count the sides, and so that's 4 sides into my formula. Oh, this isn't going to work. Let's do this. So n minus 2 times 180. That's 4 minus 2. 2 times 180, or 360. Okay. The diagram shows a convex polygon. What is the sum of the exterior angle measures? Okay, and they specifically even say 1 at each vertex. That is nice of them. So I know the sum is 360 degrees if there's only 1 at each vertex. The diagram shows a convex polygon. The sum of the interior angle measures of this. Okay, so again it's n minus 2 times 180. There's 1, 2, 3, 4, 5 sides. So 5 minus 2 times 180 is 3 times 180, or 540. You'll start to get more and more comfortable with how many degrees they are in our common shapes: triangle, quadrilateral, pentagon, hexagon. Oh, so now we're actually solving. So now notice, if this isn't a regular shape and it doesn't give us other angle measures, we'd be totally stuck. So I'm really hoping this is a regular shape. So it shows a regular polygon. So that means all 3 of the angles are the same. What is the value of x? Well, I know that the total of the exterior angles is 360. And there are 3 equal angles because it's regular. So if there's 3 equal angles totaling 360, I just take my 360 and divide it by 3. So each one by itself must be 120 degrees. Notice too that this is supplementary to the interior angles, and if this is a regular polygon, that means it's an equilateral triangle. So we know it's 60, 60, 60. And so we know 180 minus 60 must be 120. So just another way to kind of double check or approach the problem differently. Okay, so this is a regular polygon. Nice, because again, otherwise we wouldn't know. We could have one giant angle, one small angle. So, regular polygon, 4 sides, interior angles. So n minus 2 times 180. That's 4 minus 2 times 180. That's 2 times 180, or 360 degree total. And that's my interior angles, okay? So I know there are 1, 2, 3, 4 equal angles. So 360 total divided by 4, each one must be 90 degrees. Now notice too, if this is a regular polygon, a regular 4-sided figure is a square. That is all angles 90 degrees and all sides congruent. So yeah, each angle is 90 degrees. I had the hardest time writing 9s. I start at the bottom, which is just odd. Okay, what is the value of x? Again, this is a regular polygon, so I'm going to go ahead and say 1, 2, 3, 4, 5, 6, 7, 8. So this is an octagon. So n minus 2 times 180. This is 8 minus 2, or 6, times 180. So that is 1080. And there are 8 congruent angles here. So we take a 1080 and divide it by our 8 congruent angles. So each angle by itself must be 135 degrees. Again, you could use a calculator for that. I know this because I'm just pretty used to this one. Okay. Oh, it read that last one, 135. My bad. Well, we're going to stop there on the error. I hope you enjoyed this video, and I'll see you next time.